When you order a pixel goggle kit from Adafruit, you get a number of things, comes in a box. The first thing you get, of course, is a pair of goggles. These are your standard welder goggles, except they're not ANSI approved, so don't go trying welding with them. But for all intents and purposes, it's the same thing, right down to the darkened lenses. We'll take those apart later when we mount in the next piece that we see here, which is you get 2 pixel rings. Okay, now what the pixel rings are is individually addressed LEDs that can be any color, any brightness, all determined by how you program them, how you send a signal. And they can turn on and off in a split second, so you can actually simulate motion with them. They have a power in, positive, negative power in, signal out, so they can be chained together so that you can do very complex patterns or duplicate each one. You also get some wire, of course, nice piece of ribbon cable, or you can just use regular single conductor wire if you wish. I do recommend that you stay away from solid wires. There'll be a maintenance nightmare in the future. Try and get stranded wire, something in the 22 to 24 gauge range, and multiple colors, because you will be using a lot of wires and it helps to keep things straight. You also get a battery charger. This is very nice because it plugs into a USB port, and then the wires here you hook in to charge the battery, and it's all built right in. In our pixel goggles, we've actually made a 3D printed case where this is actually stored in the goggles. You can't lose the charger because they're actually slide out of the 3D case that that holds the circuitry on the pixel goggles. And of course, where you have a charger, you have to have a battery. This is a small lithium-ion battery. I think it's 150 milliamp hour. It says here on it. Yeah, 150 milliamp hour, 3.7 volts. 3.7 volts is what your microprocessor runs on. So this is called a trinket. It's made by Adafruit, and it has, well, 3 or 4 inputs depending on how you task certain inputs on them. They can be used for different things, but it has enough inputs for what we're going to be doing here. We need 2 inputs for the circuit that we're going to be building. One's input will, one's an input, one's an output. They're multi-purpose pins. We'll be using one of the pins as an input to pick up, connect up to the switch that changes the different patterns of the lighting, and the other one we will use as an output to send the data to the pixel lights. Now, this is what you basically get because they anticipated that this would be a project where you would have only one pattern, and you would plug in the battery and away it would go, and the lights would be covering the space here. All the circuitry would be packed back inside here. The only problem with that is you can't wear the goggles over your eyes because it's full of electronics. And so you have to wear them on your forehead. I said, there's got to be a better way. So I designed a little 3D case, and the address for the STL files to print your own 3D case is in the notes. And then by putting a little case here on the side, that means that we can keep the center of the pixel goggles free. And everybody out there that says, well, how can you see through them if it's got flashing lights on it? Because the flashing lights are pointed away from your eyes. You can tell that they're there, you can tell that they're flashing, but they do not interfere with vision. As a matter of fact, the tinted lenses bother you more than the flashing lights. So let's look at a couple of the other things. I don't have a spare 3D case right now, so when we look at the finished product here a little bit later on, you'll see the 3D case. This button is used to change from one mode to another. It's just a momentary button, and each time you press the button, you get a different pattern. And I believe that the file that we have, the program that we have written for it, has 8 or 10 different patterns, and plus a auto pattern, which means it'll just go from one to another, change patterns every 30 seconds. And then we have a very tiny on-off switch. And actually, this needs to be a single pole double throw, because in one position, it's connected to the charger and you can plug it in, charge the battery. In the other position, it's connected the battery to the trinket, the CPU, the Arduino, and operate it. They recommend that you do not connect the charger to the Arduino because of the slightly higher voltage and current to charge the battery. So this serves as not only an on-off switch, because it's either on or off, and in the off position is when you can use the charger. So let's look at a finished pair. One of the people that I tutored here made this pair, and she used, as you can see, the ribbon cable, and you'll see that some of the wires would be in front of your eyes, but you can still see through them. Okay, you can see the 2 pixel rings in here, and on the side here we can see the little 3D printed box with the on-off switch, or on and charge, whatever you want to call it, and then the mode change switch. And if you look in the end here, you will see barely sticking out right here the charger, which you can pull out and plug in. And this one's being obstinate, but there it is. Okay, so the charger is built right into this same box. So let's start talking about tools. What tools do you need to build this? Obviously, you need a 3D printer, or you need a pre-printed case. Other than that, you really only need 2 tools. You need a good pair of wire strippers. I recommend, something of this design, where you got all the different wires. But seeing how I mentioned 22 to 24 gauge wire, and this only goes up to 20, so the wire's a little thin for these. Try and get some that go to 22, 24, maybe even as high as 26 wire. They're hard to find though. If you get these, the only thing you're going to have to do when you strip the wire is when you close it and you go to pull the wire out, you're going to have to pull it at an angle. So that makes the hole smaller as you rotate it. Okay, so you need a good pair of safety goggles. I'm sorry, strippers. I just read safety goggles on the side here. Anyway, the other thing you're going to need is a decent soldering iron. Now, you can get soldering irons that's just a pencil like this, or, give me a second to move the camera, you can use an entire production soldering iron that looks like this, where you can set the heat, the temperature on, off. There's also a little sponge that goes in that tray under the soldering iron to keep the tip clean. And I strongly recommend you buy those. They're not expensive. I picked one up off Amazon for $15. So yes, it's definitely worth an investment. And with being able to control the temperature, you can solder by either of the 2 methods. The first method is set your iron quite hot. That means you can solder fast, and solder fast. Because if you heat up some of these things too much, they don't like it and they die. Or you can set the temperature lower and take your time. I like to set the temperature as high as it'll go, and then I get everything set right there, and then it's just a touch, less than a second, then it's on the circuit. But as we go into putting things together, we'll talk a little bit more about that. Okay, the first thing we're going to do here is we're going to take our red wire that came with our charger, it's got a plug on the end, and we're going to strip back a little bit of it, maybe 3/16 of an inch, and we're going to connect it to one of the sides here. Doesn't matter which side. You just connect the red wire onto there, put it through, bend it over so you have a good, nice mechanical fit, and then solder it. If you're using heat shrink tubing, make sure you put a small piece of heat shrink tubing on the wire and slide it all the way up to the end here before you solder that down. And then when you get the solder connection made, then you can slide the heat shrink tubing down and cover the connection, heat the heat shrink tubing up with either the barrel of the soldering iron or with a disposable lighter, which is what I prefer to do. All right, don't do anything with a black lead yet. Now, you can take the battery, and here we don't need this connector because it's not plugging straight into a charger. So you want to cut this wire somewhere in here. I usually cut it 1/3, 2/3, because you don't need much wire because it's going to be right on top of the rest of the system. So I cut that there. All right, strip back about 3/16 of an inch. Connect the red wire to the center lug of the switch. Then you're going to get some of your wire, either the individual strands you get or some of the wire off the ribbon cable. And typically red and black, as you can see on the other two cables in the battery, are red being positive, black being negative. But because we're using the stranded cable, I think what I would use here is I would peel off this gray and black, use gray for the positive. So if you're using this, take the gray wire and connect it to the other side of the switch. So you have the plug to the battery charger on one side, red wire, the gray wire or whatever you're using for positive wire on the right side, and then the red wire from the battery connected to the center. That way, when the switch is in one position, the battery is connected to the charger. When it's in the other position, the battery is connected to what's ever going to be in the end of this wire, which is going to be the trinket. So if we take the trinket and we look at this, we'll see that here there is a connection for bat. Okay? That's where the red wire for the bat, or gray wire in the case of what we're doing here, is going to connect to bat. And right next to bat is a ground pin, and that's where the black wire is going to connect. This black wire, the black wire from the charge cable, and the black wire from the battery all get soldered together. Do not put heat shrink tubing or tape on it yet, because we have one more wire that needs to go on this. So we're also going to connect two wires, any color, doesn't matter, to this switch. There are two little brass copper tabs here. Because there's no hole in it to hook the wire in, you have to take some needle nose pliers, either the ones in the tip of our strippers, or I like to carry a little pair of jeweler's needle nose pliers, very small. Make a little loop, hook it over there, and solder that on. A wire on each of these tabs. Doesn't matter color or polarity, because it's just a switch. Now, in the final assembly, now that we have these in the goggles, and we have the extra wire, the shorter one of the two that we put on the left eye, and I keep saying left because I put my box on the left. You could do the same thing, put the box on the right, and then everywhere I said left would be right. But let's assume we're putting the box on the left. So the data out wire is going to go here and connect to pin 2 of the trinket I'm sorry, the data in wire. Data comes from the trinket. The data in wire goes to pin 2 on the trinket. The plus voltage and the 5-volt DC plus voltage and ground. Obviously, the ground wire goes to ground because that's both ground for signal and power. It even says that, power, signal, ground. Okay, again, the long wire because the short wire goes to the other ring, pixel ring. And then this 5-volt, because the trinket runs on 3.3 volts and your battery's 3.7. Anyway, it's a 3-volt system. The trinket provides a 5-volt output. Down here, you'll see there's a 5-volt. That's not an input, that's an output. So it takes this 3.3, 3.7 volts that comes in, and it ups it to 5 in order to power the pixel lights. So you're going to hook that to the plus power. You're going to hook the ground section of this to the ground wire. This is where I said, don't insulate the black connection you made yet of the through wires, because you can put this there, the 4th one, and that will bring all of the black wires together in the same connection. Once you've put the 4th wire on, then you can go ahead, put a small piece of tape or heat shrink tubing over that, heat it up, and seal that connection off. Okay? And then the 5-volt goes here, and the signal 2 goes to pin 2, which is on this signal in, because signal out went to the signal in of the other pixel ring. Then carefully place all of the pieces, the trinket, the battery, and the switches into the case. You may find it interesting, or you may find it useful to put the switches, actually glue them to the lid with a little bit of plastic cement or maybe hot glue gun, whatever. Just make sure that you don't get glue on the moving pieces so that your switch doesn't work anymore. Then you put it together, all you need to do is program it. In order to program it, you got to plug this into the Arduino programmer, which is a free download on the internet, and then plug a USB cable in here. If it doesn't automatically connect and say it's connected, there's a little reset button here. That's all covered in the instructions that come with the programmer. Okay, but that's where the little reset button is. Okay? And then at this point, even before you close the box and that, everything should work. As a matter of fact, I strongly recommend, once you get it soldered up, even before you put it into the box maybe, give it a test run. See if it fires up. See if the lights run. Then assemble it, and it's done. Now, as I said, the base kit that comes in the box, we just talked about how to assemble it, and it gives you all the different functions. But again, that's just a start. You can add on all kinds of things. For instance, this is my pair, okay? And as you can see, I have changed the, move the camera here so you can see a little better. I have changed all the straps on it. And I used an old strap from a face mask, and all I did was I took all of the other stuff off, cut 2 circles in the face mask and trimmed it off short, and mounted the goggles on there. But I've also added 2 circuits. This is where those other 2 connections come in. The first one is this little piece right here. This is a light sensor that I picked up in a kit of sensors. And what it does is it sends a signal through to the program and says, make it brighter or dimmer based on the ambient light. So in bright light, they're brighter, and dark light, they're dimmer, because my wife used to complain it was too bright whenever I'd wear them in a darkened room. You'll also notice that I have on mine, clamped onto here, a articulated arm with a magnifying glass. So one of the settings in my program is all lights on white, and then that becomes an illuminated magnifier. So, and then the final piece of mine is this little rangefinder here. It's ultrasonic rangefinder, and in one particular mode, it will send a signal to how far to the object I'm looking at. Mine are also different because I added in mine a third pixel ring on the inside. And that pixel ring not only tells me what mode is currently operating, because it's on my side of the goggles, but also when I'm in rangefinder mode, it'll go longer and greater. You know, it's kind of sweeps up and down based on the range to the object I'm looking at. So even in total darkness, with my goggles on, I can see where I'm going. Oh, the other thing I added is instead of the 150 milliamp battery, I used a cell phone charger, small one, and added it to the straps, and then I can plug that in because I soldered a short piece of USB cable onto my charger, so I can plug them right into plug it right into the cell phone charger, and I can wear them for days on end if I needed to, but it just was convenient. So those are modifications that you can add, not covered here, nor is the software additions that you need to make those extra features work. But drop me a line, send me a message, or stop in at Factory 2 if you're interested in the mods. But build the goggles first. You can always add the mods in later. And I'm going to reach out here and I'm going to hit the mode button, which is right under your finger. And now we see a different pattern. The base goggles does these patterns, these different patterns, and your mode switch does the same as the one I just hit.